We've explained why uniform circular motion leads to centripetal or center-seeking acceleration. Now we're going to talk about the intuition for the magnitude of this centripetal acceleration. So remember, it turns out when an object is moving in a circle, acceleration is towards the center. And you can see this by drawing the velocity vectors, subtracting them, and seeing that the difference between them points toward the center. So the question is, what is the magnitude of this acceleration? Let's try to get some intuition for what this magnitude is and how it varies with the magnitude of the velocity with which the object is moving and the radius of the circle. So first, let's see what happens when the velocity of the object increases. Well, when the velocity increases, the object is moving around the circle faster. So the difference between the two velocity vectors, when you subtract them, is larger. So the magnitude of the acceleration should increase with larger velocity. Now what happens when the radius of the circle increases? Well, when the radius of the circle increases, if velocity stays constant, the object kind of makes less progress in moving around the circle in the same amount of time, because the circle is larger. Thus, the magnitude of the acceleration should decrease. So what's the formula? We'll actually derive it in the next section, but it turns out the formula is the magnitude of the velocity squared divided by the radius of the circle. This turns out to be an extremely important formula in mechanics that comes up over and over again, and in particular comes up when deriving Kepler's laws for planetary motion.